Now, this idea of the beginning, it having a beginning, has led to a series of speculations that go by the name the Big Bang. Basically, the Big Bang says first there was nothing, and then it exploded. If that makes sense to you, you're welcome to it. But the first model, called the steady state model, Einstein admitted was his biggest mistake of his career. It was replaced in the 60s or by the hesitation model, which was refuted in the 60s for a number of reasons. Then it was replaced by an oscillation model. It expanded and contracted, this kind of thing. And that's refuted by the entropy laws and also the lack of mass. The current thinking is pretty much along the lines of what's called the inflation model. The problem with it, it requires anti-gravity forces that have never been observed. So these are just speculations. They're attempts by people to speculate on how it all began. There's another factor, and I'm going to call it the stretch factor. The expanding universe appears to be involved in expansion of about 10 to the 12th. And that comes from the temperature of the quark confinement when matter freezes out energy. And we don't have to go down the physics path there to justify this estimate. But it's interesting that with an expansion of 10 to the 12th, scientists estimate that the universe is about 16 billion years old. Well, that turns out to be about 6 times 10 to the 12th days. And so with that expansion factor, you come to the same term that God himself used with his own finger when he wrote it in stone in the book of Exodus chapter 20, that in 6 days it was created. If you take the exponential factor, it would imply that these days from God's point of view are 15 billion years old. What kind of clock was running at the time? We don't know because Adam hadn't been created yet. So it depends whose clock you're talking about. And there's a whole issue there of just how old the earth is. It turns out, can it be 6 days or 16 billion? Both are probably true, each in their respective frames of reference. But stretching the heavens, let's talk about the fabric of space. Is this more than a metaphor? In the scripture it speaks of God who alone stretches out the heavens. In Psalms, he's stretching out the heaven like a tent curtain. In Isaiah, he who stretches out the heavens like a curtain and spreads them out like a tent to dwell in. He has stretched out the heavens. The Lord who stretches out the heavens in Zechariah and so forth. We have literally dozens of references where this same term is used throughout the Bible. Is it just a figure of speech? Today we discover that space is not, as most of us suppose, an empty vacuum. It can be torn, according to Isaiah 64. It can be worn out like a garment, according to Psalm 102. It can be shaken in a number of references. It can be burnt. It will be burnt up, according to 2 Peter 3. It can split apart like a scroll in Revelation 6. It can be rolled up like a mantle or a scroll, and both Hebrews and Isaiah use that frame of reference. Well, that's an interesting clue here, what we're talking about, the properties of space. We know today that empty space has an energy level that's astonishing, 100 million suns equivalent, 10 to the 95th ergs per cubic centimeter. We'll talk about that in a minute. It has permittivity, magnetic, or actually a dielectric constant. It has permeability, a magnetic constant. Any amateur radio operator knows he's got to tune his antenna to the electrical properties of space itself. The intrinsic impedance, which derives from both of those, and then the velocity of light, which is presently estimated to be more than 2 times 10 to the 10th its present velocity at creation. It's currently at the speed of gravity. And the fact that the velocity of light has been changing is the astonishing discovery of just the last few years. And so there's a major upheaval going on in the field of physics as we realize that these things we thought were constants are not constants. And we'll talk about that in a minute. Zero-point energy. If the temperature of an empty container is lowered to absolute zero, there still retains a residual amount of thermal energy that cannot by any means be removed. So that's why they call it the zero-point energy. What we think of as a vacuum, we now know is a vast reservoir of seething energy out of which particles are being formed and annihilated constantly. Why doesn't an electron, as it spins around its nucleus, get attracted by the nucleus and simply radiate energy and spiral into the nucleus? You get the picture there? You'd think it would just disappear. It picks up energy from the background zero-point energy and therefore is sustained by it. So there is a sustaining going on right at the atomic level. How about being rolled up? There's some dimension in which space must be thin if it can be rolled up, and it also must have some direction that it can be bent toward. So these terms in the Scripture give us a clue that there are dimensions to space beyond the ones we experience. You and I think of a three-dimensional space, length, width, and height. Three dimensions are what we think of embraces space. We now know today there's more to it than that. There are additional spatial dimensions, and the Bible has said that all along. So let's talk a little bit about hyperdimensions, which is simply a term for spaces of more than three dimensions. And we're going to go beyond Euclid. Most of us have taught in school what we call Euclidean geometry. But it turns out that the most important speech in mathematics was given on June 10th of 1854 when George Riemann introduced us to metric tensors. The mathematics, it took 60 years before that mathematics would yield the theory of relativity by Dr. Einstein, which he discovered in 1915, a four-dimensional space-time. We're going to talk a little bit about that in more detail in the next session, but we know today that you and I don't live in three dimensions, we live in at least four. Length, width, height, three spatial dimensions, and time is a fourth dimension. A physicist will never speak of space or time separately. If he's careful, he'll always speak of space-time. Space and time can't be separated. The Planck's constant is a four-dimensional constant. And Kaluza-Klein in 53, Einstein went to his death frustrated because he couldn't resolve other issues. If he'd done the same thing he did to resolve the first one, simply go up a level, it would have yielded. And in 53, a couple by the name of Kaluza and Klein went beyond the four dimensions and resolved the light and supergravity issues. And then in 1963, Yang and Mills went further to establish the electromagnetic and nuclear forces, combining all of them into a multidimensional perspective. And in 1984 and following, the current speculations have to do with superstrings. Most particle physicists will tell you they believe we live in at least 10 dimensions, not just the three that we directly experience or the four, including time, much more than that. The dimensions of reality. It's interesting to notice that an ancient Hebrew scholar by the name of Nachmanides, who wrote in the 13th century, in his commentary on the book of Genesis, he concludes that the universe has 10 dimensions. Only 4 are knowable in his vocabulary. 6 are not knowable. Well, particle physicists today, in the 20th century, have discovered, or they now believe, that there are 10 dimensions. 4 are directly measurable, 3 spatial dimensions in time. 6 are curled in less than 10 to the minus 33 centimeters, and thus are inferable only by indirect means, because they're smaller than light itself. This fascinates me that we've spent millions of dollars building atomic accelerators to discover what Nachmanides discovered by just reading carefully Genesis chapter 1.